Hi, and welcome to the episode 3 of Make Your Own Damn Plugin. So now we are finally getting hands-on developing in C++ our very own delay plugin. And now it's highly recommended that you take a look at the episodes 1 and 2 so you can easier follow what the heck I'm doing here. So let's now just jump right into it and let's start with a new plugin. So make your own damn plugin, create, and let's give it a name. I will call it amazing delay. And now we have our new amazing delay code base here. So we have the CPP file, a header file, we have a turtle file for it, and the manifest file. Now if I would now take a look at Kala and see the plugins, there's nothing amazing here, so we need to build and install it. Let's do that. So make your own damn plugin, build and install amazing delay. And now if we take a look at Kala, we can see that now we actually do have an amazing delay here, and it has a volume knob. And if you take a look at here at the wrench icon, we can see from the parameters that it also actually supports enable. So it has enable and volume, and at the patch bay we can see that it has one input and one output. So it's a mono ideal amp. So if we take a look at quickly the turtle file, how it's defined there. So in the turtle file we have the input port, which is the audio in, we have the audio out port, and then we have the enable, and then we have the volume. And here we can see that we have the minimum is 0, maximum is 2, we have the default value of 1, and so on and so on. So now that we are doing a delay plugin, probably we don't need volume, we need feedback volume or just feedback. Let's call that feedback. And then let's also add, obviously we need to have the delay has a time period when the delay happens. So let's just call that a delay. So I'll just copy paste a new port here. Index needs to be unique. So there's like 1, 2, 3, 4, or sequential. I guess it has to be properly. Let's call this just delay. And delay. Now let's think about the value. So the feedback is also like a fraction of the original signal volume. So I guess it would make sense that the maximum is 1, which would be like the original signal, minimum 0, and default probably like half. So then you get like a decay of half for your feedback by default. The delay, I guess this could be in seconds since we have the fractions here. So I guess the default can be 1 second, maybe the maximum delay would be 10 seconds. Now the minimum, let's say 50 millisecond, like that. 50 millisecond is the minimum delay. Let's go with that. Okay, so now if I just save this, and I still have the Kala running, so let's quit that, and now build and install it again and check the Kala. So now we have feedback and delay here. So if you take a look at the parameters, we have feedback and we have delay value, and also the enable here. We still should have the audio input and output. So now the turtle file is done. Then the next thing we definitely need to do is we need to link these that we defined here in the turtle file to the actual code. So we have a feedback and we have delay. So if I go here to my amazing delay, and here's the connect port. So here we are connecting different indices to those things that are defined in the turtle file. So we have the enable, so that's going to be as it is. The volume, so this would be MPF and feedback. And by the way, MPF, this is a notation that I use, member pointer float. That's just how I like to denote this. So this is a class member variable, which is a float pointer. So let's go to the delay here, the header file. So it was this one. Let's just rename it like that. Then we also had the delay. So it's also member pointer float delay that we need to have. And also we of course need to initialize them here to null. Always initialize as null those pointers. So like that. And of course we need to link the index 4 to the index 4 to the delay. Like that. One more thing, here at the run function we can actually remove some of the comments here, we don't need those. Here at the run function you always want to check that everything that is defined here on the connect port is also validated here, that the pointer is not null. You want to check that, because if the pointer is null, then it means that there is some sort of issue between the host application and the plugin itself. So in that case you don't want to do any kind of processing, just return immediately. So now we validate the pointers and everything. We don't do anything particular here. We can actually just like comment that out like that. So here what we do is, if it's enabled, we will pass the sample from the audio in buffer into the audio out buffer, and if it's not enabled, then we will pass 0, so it will output nothing in this case now. And if this looks weird, so this is not a multiplication, this is actually dereference operator, because this is a pointer, and when you dereference a pointer you will get the actual value. So dereference of a float pointer is actually a float, and float is kind of like a decimal value. So here, for instance, when we have a multiplication of a dereferenced pointer, so that just might look weird because there's two two stars like that. Anyway, next thing what we need is that ring buffer. So we need to start remembering old samples so that we can actually then get them and mix them like this to the out buffer. And what I'm thinking is I want my buffer to be something that I can index, so that when I have a buffer with index 0 would be the latest element there, and with, let's say, with index 1 would be like the second latest element, and so on and so on and so on. So I will implement that kind of ring buffer now. Also, I obviously want to push the audio input buffer somehow. So if I have here a buffer dot push and just give the input buffer and sample count like that. So I want to push those to the buffer, and then I want to use the buffer like with the indexing operator like this. So yeah, let's implement that. I will do it as a header file. So let's just create a new ring buffer header file with a public section and a private section, having a constructor that takes the capacity of our ring buffer. That will be a size t. Oh. Like that. And then what we need is the actual buffer, and because we don't know the buffer size, so that we could do it as a stack allocation at this point, because we are passing it as a constructor parameter here. So that's why we need to do actually a heap allocation for the float pointer buffer for the float buffer. So let's do that like that. And then we obviously want to clean out the buffer at the destructor. And we also want to zero the memory of the buffer, so we can do it with, let's just do a new function for that. So like that. So also here a pointer validation before checking. It's always good to validate pointers. This is now designed so that I should always use this constructor and nothing else. So I will actually hide the default constructor like that. All I need to do is I just define it at the private section, so it cannot be used anymore after that. Then what we need is that push function. So we need to push stuff into the buffer. So in order to push stuff there, we actually need to have some sort of position where we are at the buffer. So let's do that. So we have a size t position And then let's have a function here to void one. And we will add for the buffer position. We'll add whatever there is in the input buffer at the index I. At this point, then we will increase the position, and then we will check if the position now equals the capacity, which is already over the index that we should be. And if that is the case, then we will zero the position back to 0. So that's how we can get a ring buffer that when you fill it, then it starts again from the beginning. And by the way, some would probably use modulo operator here, but it has two drawbacks. It's, as an operation, it's much slower, because this is also this if condition is really easily predictable. So Brad's prediction can make this loop go really fast. And the other thing is that with the modulo operator, you would probably keep just increasing and increasing and increasing the index, and it would at some point overflow. So yeah, this is my recommended approach for that. Yeah, I think that's completely fine like that. Well, I don't have the pointer validation here. Yeah, I guess we could do that. It's not costly. So if no buffer, and just return. Okay, so now we will need an array indexer, and that would then return a constant float reference to whatever there is in the buffer. So this is override of the array operator. Now, so if we are asking index that is bigger than our capacity, then we are actually asking something that is older than we are able to remember. So that is the first case. So if the index that is asked is bigger or as big as the capacity, then we are already over the last index. Then we need to return something default. So default would be a 0 in my opinion, but because it has to be a float reference, I think I actually need to have a 0 value here as a private member. So let's do a constant float, const float 0 like that, and initialize it as 0 and return that 0 value, or reference to that 0 value in this error case. Now the next case is that if you think about that, we want to go to the past, or we are at some position in our buffer. So if we want to have one sample ago, then we will go from that position -1 and we will return that one. But the thing is that if the index that we ask is actually bigger than the position, then we cannot do the minus operation, because also that the size t is actually an unsigned long. So if we do the minus operation, we are not getting actually minus number. It will overflow and we will get some large number and so on. So we actually need to be a little bit sneaky about this. So if the index that is asked is bigger than our current position, then we need to return from the buffer our current position plus the capacity. So that's, we can then move it like around ahead, and from that we can reduce the current index or the index that has been asked. So that's how we get to the correct index without having an overflow issue there. And then we have the last case, and that would just be when we return the buffer element from the buffer, it would be the position minus the index. Then that's it. I guess we still have the validation. We should do that as well. So if it's null, then we will return 0 as well. Yeah. So I guess that's the ring buffer pretty much. I think. Let's try it. Let's go to the delay here, and then we actually need to have the ring buffer here first. So let's include it like that and have it here as a member variable, ring buffer Ringbuffer like that, and initialize is here at the constructor, and here we need to give it now the size of the buffer. So we need to give like the maximum size. So it's always better to be bigger than smaller. Obviously it takes more memory when it's bigger, but yeah. Let's do something like, if we wanted to be able to do like 10-second buffer, then let's do 10 times the sample rate. So that's how we get the buffer. Oh, why is it complaining? Let's see. Oh, I'm pretty sure it's all right. There's just the intelligence here is probably complaining something. Anyway, we don't have to care about that. Let's push stuff to the Ringbuffer. And here we should be able to use the buffer. Okay, so next thing what we need to calculate is the gap of the sample, because we have a delay now as a value in seconds. So what is the delay gap in samples? So that also would be a size t. So let's just call it gap. So the gap would be how many seconds. So that would be dereference of MPF delay. How many seconds times the sample rate that we have, and the sample rate I have in the class variable like that. So that would be the gap in samples, how much we want to go back in time to retrieve those samples in order to do the delay effect. But also because we have here actually a buffer, and we are looping over the buffer, the gap is actually also, we also need to take in account this one, so we can actually increase the gap with the sample count -1, so we get the last index like that. So now to the audio output buffer, we want to add the audio input, but we also want to add from the Ringbuffer, we want to add something gap ago minus the index that we are now rolling. So that we just want to add there, and we want to add that by multiplying it with the feedback volume value that we had. So that would be the MPF feedback, and I think that's it. So we can put that in parentheses so it looks a little bit more neat. I think it's actually there. I don't know, there might be a million bugs, but let's build that. Now I need to take my headset to check if it actually works or not. Cha, 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 cha. It works. It works. It works. It works. Cha, 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 cha. Yeah, also the feedback volume works. How about the delay? 1. Ja. There's some sort of crackling. Ja. There's some sort of crackling. So I think that the delay 10 seconds actually goes over the buffer, so that's why we are hearing the crackling. Yeah, so the buffer is slightly too small, I think. So if we take a look at the what did I do? I have a 10 second times the sample rate, and then it's probably asking also samples. So the gap is going to have also the whatever the buffer size is added there. So yeah, it's a little bit too small. So that's why we have a little bit of crackling sound there. We cannot hear like, I don't know, 15 seconds like that. But you know, that will just fix it. I will not test it again. This is now completely valid delay plugin. Cha, cha, yeah, yeah. Cha, yay, woohoo, hee hee, hello. So, thank you for staying with me these 3 amazing episodes that I just pulled out of my hat, basically. There's probably not going to be a 4th episode. I think I'm going to go back with recording some music on my channel. Let's do the next nerdy stuff at some point, I guess. Thank you, and please leave a like, subscribe. It makes me happy. Thanks. Bye.